I think we're at an amazing time in sort of the history of pancreatic cancer research and the implications of that for treatment. I think for our group in particular, there's sort of two domains that I'm very excited about. The first has to do with the tools of genetic engineering that have become available to us in the last several years. We're now in a position to model human pancreas cancer with tremendous precision in weeks compared to what used to take years. The other domain that we're very focused on is how does the immune system see and fail to see pancreatic cancer? So we've worked very hard to build models of the disease using the mouse as a system in which we can provoke an immune response on the one hand, and then observe that immune response failing. And then our goal is to reverse that process through the addition of drugs and other means, allow the immune system to fight back, see the cancer, eradicate the cancer.
I'm really interested in understanding how cells change over time and in relation to the different treatments they're exposed to. When we sequence all of the cells within a tumor, we can actually build a family tree of how those cells are related to each other, which we're hoping is going to let us understand better how the cells are responding to the therapies that we're throwing at them, and hopefully predict how they will respond in a patient and then be able to come at them with maybe a second treatment or a better drug that will help make their tumor go away.
I am really interested in trying to figure out vaccination targets in PDAC by looking at both human organoids that were derived from patient samples as well as in our mouse pancreatic cancer models in a dish, as well as targets that we find in mouse tumors. And I think with the advent of lipid nanoparticles and mRNA vaccinations, that this will really be a nice system to, when a patient comes into the clinic, for instance, and is able to get a resection, we can then sequence that tumor that the patient had, figure out what proteins are specific to that patient's cancer, and then develop a vaccine for that.
Basically, every single line shows a patient carrying mutation in one of the epigenetic regulators. And we already know that this dysregulation of these pathways can basically promote the tumorigenesis. So the goal of my project is to understand how these known pathways are being changed during tumor initiation, progression, and metastasis, and how potentially we can target them. Since even today in the clinic, there's already many different inhibitors that are being used in the patients, but not specifically in pancreatic tumors. So I'm trying to understand how we can learn from what we already know in development in different tumor regions into translating into PDAC progression and hopefully better survival for PDAC patients.
My main, I guess in a nutshell, what I'm looking at is trying to purify T cells from that model that I've adoptively transferred in, and identify metabolic changes at early and late stage tumors to see if there are some changes that we can pick up on that may lead us to more insights about how we can reinvigorate the immune system in this specific model, since, as you all know, PDAC has a very cold immune response.
So, Andy, I'd like to take a moment and express my gratitude to the donors of the Lustgarten Foundation, the folks who fund you to support people like me. Everything we do requires funding, and the bulk of the funding that we get for pancreas cancer research comes from the Lustgarten Foundation. So all the experiments that we do, all the results that we get, all the promise that we can deliver is really owing to the fact that your donors are willing to give their hard-earned dollars to support this cause. So on behalf of my laboratory and my institute, I just want to thank them at this time.
Yeah, and I couldn't agree with that more. And it's a very special group of supporters and donors and people who've been touched by this disease. And it is clear, I think, from the outset for the Lustgarten Foundation, we are where we are because of our supporters. And all of the great progress that we talked about only happens because people step up and say, we want to make this happen.
Exactly.